topic. Can I have your attention, please? Trigonometry. Trigonometry part 3. What we're going to look at tonight is what's called the compound angle formulae, of which there are 4, and then a couple of more derived ones for tangents that we won't be worrying too much about. Okay? And then what we'll do is learn how, I'll teach you how to use those compound angle formulae to simplify trigonometrical expressions. Thirdly, so that bit, the second one there, is around what I'd asked you to do in the pass criteria in the assignment. Okay? Within the, what is a distinction task, I believe, you will need to be able to convert expressions in the form of a sine omega t plus b cos omega t into our familiar r sine omega t plus alpha form, using the compound angle formula. Alright? Sounds more complicated than it actually is. Hopefully, anyway. Well, when you say it, that's never that understandable, Daniel, is it? But when you actually go through problems, still not. Right. On the second page of your handouts, I have summarised the 4 compound angle formulae that we're gonna be using. If you don't listen and you sit up the back and chat, you won't get this. With me on that. So, first one is that the sine of the sum of 2 angles. So we've got 2 unknown, any angles A and B added together. The sine of those 2 angles added together is equal to sine A cos B plus sine B cos A. First formula. The sine of the difference of 2 angles, the sine of A minus B, is sine A cos B minus sine B cos A. Don't expect you to learn these. They're always going to be there when you do your coursework. You just got to find the right one to use to simplify the problem that you've got in front of you. And it's about having a different way of writing something. You might have an expression in that form, and to solve the problem, you need to write it in that form, or vice versa. That's all. Able to write an expression in a slightly different form, manipulate it, and that's this topic. No. Then we've got similar thing for the cosine of the sum of 2 angles, difference of 2 angles. And you probably don't think of it, but subtraction is always about the difference between 2 numbers. How the difference, if 4 minus 2, the answer is the difference between the numbers 2 and 4 on the number line. The answer is 2. Yeah? One use of these is to express a complex expression like the right-hand side of the formula. So these ones, a complex expression, as the sine or the cosine of a single angle. If this was 30 degrees and 40 degrees, we can express that as the cosine of 30 minus 40, which is the cosine of plus or minus degrees. You see that? So let's have a look at the example on the next page. Using your calculator, okay, we want to be in degrees mode. Evaluate the expression to 4 significant figures. So I want to know what sine 12 degrees times cos 67 degrees plus sine 67 times cos 12 is. Top. Oh, times cos B minus sin A take that top expression as the cosine of pi over 7 plus pi over 5, which is the cosine of 35 pi. So the bottom, did you get the same as what you got? Expression like okay. Combined cosine of a mass move up and down can be this function combining two waves of frequency. So we've got a sine function, 12 amplitude, sine 4 pi t, and we're adding to that 8 cos 4 pi t. See, because omega is the same in both of them at 4 pi. If we graph separately, so on your page you've got a graph there. I know yours, but my red function 12 sine 4 pi t there starts at 0, crosses there, and goes to about in terms of time. There's one side. So the blue one, it starts at the peak 8 and goes to 0, and the sine function at maximum, the cycle back to the peak. It's the same distance as it is. They're 90 degrees automatically, 90 degrees with the same frequency. The green waveform is that function of the two waveforms added. So what we'd be doing if we wanted to plot this, we'd look at what red one was and what the blue one was added together, and that's where we plot. So the green one cross here we'd be adding together that much and that much to make that much. So that is an addition to 2, and so is and then this axis here and drew a line across there. When it hits that value again, also crossing with the the frequency is equal to 1 over all 3. Combine result if we sine waves together, where one of them was out of phase with the other. And in fact, if we made a sine wave and we added to it a sine with a phase, we'd have the same situation as wave. Should you study further, particularly in electrical principles at level, if you would look at what you can describe any wave shape as a function of different sizes. Alright, in fact, a perfect wave, waves all together, and that's the way you create the kind of square wave, triangle wave signal. We're going to have plus b times the sine of omega t plus a phase angle form. The problem is, find an expression for 3 sine omega t plus 4 cos omega t in the form r sine omega t plus alpha, and sketch graphs of all 3 on the same axis. Okay, so call that problem. It involves a little bit of using compound angle formulae. If we're going to turn that, what we need to do is say that let 3 sine omega t plus 4 cos omega t equal the form that we want, r sine omega t plus alpha. So the first thing to do is say we're going to let them be equal to each other. Alright? What can we do to that to start to make things look... Can we write this differently? Sine. What are those two things? What? It's an angle at a particular time. It must be an angle because you can only take the signs of angles. Don't get hung up. At the moment, that's just a number, the angle. We don't know what its value is, but omega times t is a number at any point in time, isn't it? Yeah, at any instant in time. As we've done earlier tonight, how could we write sine omega t plus We've got to keep the R. Using the we can go the other way as sine B, this being omega t being A and alpha being B. So instead of writing A, we write alpha. So that is sine omega t cos alpha plus sine alpha cos omega t. Close the brackets. And we're still multiplying. Yep. Just gonna let's just put a statement in there using compound angle on right hand side. To the what do you think we could do next? Anyone got any ideas? What did you say, Adam? We can't do it yet. Sine omega t plus go back. We've applied the compound. Going to start it. What we need. What happened? So, it 3 sine omega t plus 4 cos omega t equals. we have to do R times these two are multiplied together, and these two are multiplied together, and do R times this bit, R sine omega t cos omega t. Yep. Cos alpha. Plus R sine alpha cos omega t. Brackets. We multiplied each part inside the brackets by R. Yep. Can anyone see what we can do with that now? And I wouldn't think you can, but let's... On that side, sine omega t is multiplied by 3. Yep. On this side, sine omega t is multiplied by cos alpha. You got it? And then, so, now can I find R? Yeah, there is. I'm trying my best, but there's too much chit-chat going on. We've equated the numerators on the coefficients of sine omega t. We've got 3 sine omega t's on that side, and we've got R times cos alpha times omega t. Sine omega t multiplied each side of that expression. 3 on that side, and R cos alpha times on that side. Where's 4? We have that's cos.
No, the other side, there's a sine omega t.
Yeah, there. That's the only sine omega t there is. Simple. Time tonight. Sine. Can we stop? Is equal to this. So we right hand side, we're going to apply the formula. is the same. Is equal to R sine that's the only difference is in this particular example you've been given a value for omega. It is 4. Now, what you're going to end is if you're going to you need to pi plotter because if you've got no value. We've got 12 sine and that rearranges to and cos 4 pi t. And where that is alpha in the output r is equal to the square root of 12 squared plus 8 squared. 4. To the minus 1, and that's alpha equals function that function s equals to r 40 plus original.
Yeah.
So that bit at the bottom is equivalent if on the left right back